Hello everyone, hello again. Yes, just an update on the presentation I gave last month. If you didn't see it, you can Google it. Thank you for recording it. It's up there, the quality is really good. You can see all that and all the details. I won't go through everything, but one of the questions in it was, well, what about the numbers? So I'd done a lot of playing with it and I was feeling really good, but the question came up, well, what about the numbers? How does it actually compare to the last one? Now it's going to depend on your use case. So I created a little test, and this is actually using some of the stuff that we use in production every day. So this is one of our boards. So I work on Jira, and we have columns of issues very similar to Trello. So what I did is I set up test conditions of 200 items. It's rendered in React Storybook. I didn't bother with any of the setting up all the nice performance production optimization stuff. It's just kind of similar across both use cases. So they're not stripping out prop types or any of those kind of nice things to make it run even faster. So these numbers will be relative to each other. So the first time I did it with 200 items, just so everyone knows, when we benchmark this, we usually benchmark against 100. So 200 is kind of doubling that to see how it goes. So the first time we did it, a bit sad. So 8 to 15 frames per second while you're dragging, which is pretty horrible. And I'll show you what that looks like. Again, it will be much higher than that when we do all the production optimizations. That's just kind of a baseline number. So when I did all the optimizations that I talked about in the last meeting, it jumped from that to this with all the same conditions, which is pretty amazing, just from jumping from one strategy to the next. I think it kind of shows the relative gains. To jump like that many FPS is amazing. And this is still using all the dev stuff, so I imagine it would probably push up much closer to FPS, 60 FPS as you go up. Yeah, fast times. So what it looks like is not like that. So this is it. Sort of with the old approach, you can see it's like really hard to move around. Not very fun at all. This is the same amount of things. Let me hide all that stuff. Ooh, buttery. So yeah, just kind of showing off the gains of that approach. Again, this will depend on your specific use case, but this is sort of using it in anger. So every little mouse move is actually a complete new re-render of the entire thing. We don't do any kind of set state tricks or any debouncing or anything like this. This is a complete re-render from Redux action all the way through. Who uses React Redux? Much? Okay. Who uses reselect? Anyone? Okay, if you're not using reselect, if you didn't have your hand up, you should probably look into reselect. It's going to make your apps a lot faster. Now, what it does is it lets you memoize your queries on the state. But really interesting gotcha with that is if you're using map state to props and you're returning inside that function an object, so you return an object, but say your object has objects inside it, Redux's shallow equal will see that as a new data and re-render it. Let me show you what that looks like. So, is it make selector, I think. Cool. So here's the use case here. And I've seen this before, and it really hurts apps. So this is an object that I'm returning from my map state to props function. Can everyone see that okay? I'll put on Zen mode one sec. Ooh. Okay, so you'll see here I have this object called offset. And what offset is an XY coordinate. And you'll see here instead I'm returning, so what I had before was something like this, and I've seen this a lot. Right, so that's an object there. The trouble is what Redux will do by default is it's going to do a shallow equal across these arguments, so it's going to go down, 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 and it's going to get to this offset. And even though it's the same value as the previous time you returned it, because it's a new object, it's going to be a new reference. So the triple equal test is going to fail. So you're going to get a new render, which is bad time. So what I've done is I've created this little memoized offset, which is using that little library I showed off last time that I've actually open source, which is pretty exciting. And what it does is it just takes an X and a Y and then returns an X and a Y there. So kind of, if these don't change, then you're going to get the same reference back. And this had really massive gain. So just something to be aware of if you're doing kind of stuff where you're using memoization and you're returning objects or like nested objects, that you don't want to invalidate those references. Really interesting tools you can use to debug this in Redux, which I wasn't aware of. When you do create store, you can actually pass in options. So if you look at down here. So inside here, I've got it commented out at the moment. But you can actually get hooks onto every little thing that it's doing. And so what I was doing is checking that at each step, what was going wrong, what was busting my cache. And this is the kind of catch-all at the end. What it's going to do is it's going to say, are my merged props, this is your own props plus the props that Redux is giving you merged into one object. And I was doing a shallow equality check here just to see what was happening, like what was wrong. And I could put a debug point in there and then kind of see what things were different, that I didn't expect to be different. That's a really nice catch to get to before it gets to your component. Cool, that's all.